Hey, what's up, guys? Today I have just decided to create a video on how bank operations can be created using object-oriented programming in Python, along with some encryption and decryption and multi-party computation that would help us to figure out about the privacy aspect also and protect the sensitive data of the customer. So let's get started. I'm very excited for this because this is a trending topic. We all should be aware about this, and there we go. I'll make it easy for you. I'll do as much as possible and make it as easy as it can be. So let's get started. Yeah, I'm all excited. So first, let's import the requisite libraries for the same. So from crypto.public key. So this is like one of the cryptographic security measures that we are taking. It's RSA library that we call it as. This will help us to find out the public and the private key, which would be used for decrypting and encrypting respectively. So from crypto.cipher import pkcs1 underscore OAEP. This is like a cipher. It's for initiating the cipher. I explain you what cipher is exactly. Import Binaski, import RE. So this is done respectively. Okay. Spelling's correct, everything correct. This one is usually for importing. It's for the creation of a public and a private key and a private key. This is what will help us to figure out how to do the same. Like it will just figure out something. It will initiate the creation of it and then initiate cipher using this library. Then Binaski is for creating 2-digit hexadecimal format, and RE is for matching. I'll tell you where we'll use it for matching. We are also going to initiate some KYC procedures for ensuring that the customer that we are onboarding is good for the firm. Like it's he's having a good credit score and he's feasible enough for being a part of the bank. So let's get started. For object oriented programming, we need to create a bank class. Okay, then we write the bank name as Axis Bank. I'm taking Axis Bank. Any bank can be written here, doesn't matter. Branch is equal to Hyderabad. Any random branch, Telangana. Okay, India. Then comes our RSA keys per time. So generating RSA keys. This is the procedure. So what is there in this? Key pair would be is equal to RSA dot generate. This would generate the pair of the key, the public and the private key pair. Okay, 2048. This is the size of the key. Size of the key is 2048 bytes. That's it. You can write any random number here, but usually this is what is used. Then public key is equal to key pair, the key pair that we defined here, key pair dot public key. Very simple it is, right? Just the brackets like that. Then private key would be, private key has a different procedure. It's like key pair dot export key. This key pair dot export key. Okay, again round brackets. Then cipher RSA is equal to this thing we'll copy here. Okay, dot new private key. Now we are going to, this means that we are going to use the private key for decrypting. What we do is we encrypt using the public key, we decrypt using the private key. That is the procedure. So we need to put this private key, it is important to put it in the bracket so that we can decrypt the data later. The bank would have to decrypt the data later so that they can of course so that they can verify the details that the customer is giving. It's not that they can perform completely on an encrypted format, right? They would have to decrypt it later. So for that purpose, they will have a private key for the same. That's pretty much it. That is done. This is the class level, guys. This is the class level, remember. Now we'll create an instance level. Instance level, that means now for each customer, we would have to store the records. We would have to initiate the record generation process and stuff like that. So I will write username, PAN, address, all these basic details that the customer would be giving for creating his account, right? And overdraft limit also, I will just simply add this element. The bank can edit it according to what is the overdraft limit for their bank, right? They can edit it accordingly. Don't forget the colon. And afterwards, self.private key. Okay, now I'm creating the private key for each and every customer. So whatever customer will give, whatever address, whatever PAN card username, whatever he gives information, for each kind of information, the private key will be generated. So that's the best part. That's why it has to be created at the instance level. This was at the class level. This was like everybody can, this is generally a private key information. Generally for it's not specific to the customer. This one would be specific to the customer. Okay, basically we have defined the private key and kept here, and then we are going to use it for the customer specifically for his information. RSA.import key self.private key. Again, now we are importing the key from RSA, the cryptographic software library. We are importing and we are defining where we are going to use it. Like the self.private key is equal to RSA.import. Yeah. Then afterwards, RSA. No, I'm sorry. We have to create a ciphertext now. We have already done private keys thing. Now it's time for ciphertext. So again, paste this dot new self.private key. Okay, done. Then afterwards we can even consider printing the private key. Like this, we should not, the bank can consider doing it. We should not generally do it. Actually, the code should be accessed only by certain set of individuals who are authorized to do the same. Not everybody can get access to this private key. This is a very sensitive information and they should not be simply randomly shared. But just for the purpose of this video and to show how exactly private key looks like, I'm going to print it out. But the bank should, in reality, they should not let it get disclosed. That's the main thing. So please remember that, guys. Then self print. Okay, we're done. Then afterwards, I would go for defining username, PAN, address, and so on. But don't you think before that I should do some definition for the KYC check, so that this username that I'm going to define will be verified against that KYC criteria, right? Maybe because KYC criteria would be something related to address having a certain length, or PAN card being of certain number of digits or certain number of alphabets and something like that, to ensure that it is authentic. We would have to do something, we would have to initiate these details. So before defining username, PAN, address under this instance level, I would go for defining KYC check. Okay, how I'm going to do the KYC check. So just follow me. So I'm just going to go for define KYC check. Self, again, I like the same as above. Self username, PAN, address, and then afterwards I will just, yeah, I put it in the correct place. Yeah. If self dot validate username bracket username. No, actually this is something that's going in my head, but you will be like, what is validate? I'll define validate first, okay, so that it's not confusing for you. So I will, under KYC check also, I would have to create some definitions for validating username, PAN and address respectively. So how will I do that? I'll show you. Self username, return bool. Bool is boolean basically, that's for true or false. So I'm going to use this read library here, read.match, okay, open string like that, this, then A to Z, capital A to Z, then small a to z plus with some space, because when we add the second name, we add with a space, right? If it's higher Fayaz, higher space Fayaz, right? Of course. Then a to z, okay, again, and it will keep adding based on how many number of names you have, like people can have n number of names, right? Plus like that. Then star and dollar. Now you will ask me, what is star and dollar? What is this doing here? So I'll just show you. Yeah. 1 minute. By mistake it has happened. Yeah, it's perfect. It by mistakenly closed there. My bad. Comma username. So what does this do? Re.match is used for checking if the username is matching this criteria. What have I done here? I have started a string with this. Then I have checked if the name is in this character limit. It should be either in the capital letters or in the small letters, right? So if it is HAYA, capital H, and then small h, small a, small y, so on. And then you can add more names. Plus is for that purpose. You have added a space so that it can be with some space, right? And so on. So I will write FAYAZ, capital F A Y, small a, small y, so and so on, like that. And then this star, you will ask me what is this star for. This star is specifically for ensuring that you can add either one name alone or many names. Star means this particular A to Z, this thing A to Z will be either 0 or more. There will be either 0 occurrences of it or more. Okay, the second one. So if I just want to keep Haya as my name, just single name Haya, this star would help me to do that. Okay, but if you want full name only, you want at any cost you want the full name, then you would have to remove that star. But suppose if somebody just has a single name, then this will help you to maintain that, because this ensures that there would be 0 occurrences of the second name, right? As simple as that. That's why I'm ensuring that this is there. Then define validate pan. Similarly, I'm going to go self pan return bool. Okay, it became a lot of indentation. Then return bool re.match. Again open this bracket A to Z, but remember this time it's a particular format that Indian PAN card has. So A to Z, it has to be capital letters 5, and then afterwards you will take 0 to 9, because first it starts with 5 capital letters, then it starts with 4 digits. So 0 to 9, 4 digits, so but with a curly bracket 4, and then again it will start with A to Z capital, but with one digit alone, with one character appearance alone. So what my point is that usually in PAN cards, Indian PAN cards, we have got 5 capital letters first, then 4 digits first, then 1 capital letter again. That is a format that I want to be followed. Okay, that is a format that customer should ensure that his PAN card is in that format. That's all. Then afterwards, I think here we did not. 1 minute, just a second. Yeah, it's correct actually. This is bracket like that. Where will we close it? We'll go, since it's just here, dollar. Yeah, then PAN. Oh, I forgot to close it, sorry, my bad. Is there one more bracket? Yeah, there is one more bracket, because we are doing this and this. Here also actually there should be one more bracket. This matches for this and this matches for this. Yeah, I forgot about it, sorry. Then define validate address. Address I'm keeping simple, self address return length of address. I'm just checking if the length of address is more than 0. Actually, it should not be this simple, because sometimes people will only put 1 or 2 letters for this. They will be oversmart. But in reality, of course, the bank should edit it according to the number of addresses that they want, number of lines that they want in their address, and so on. This is just a simplified version. I'm just showing how it could be done. Now that I've defined all this, it's time for conducting the KYC check, right? For finding out how the KYC check will be done. Now you guys will now it will make sense that what is validate username, what is validate PAN, and so on, right? Now I'll use it properly under define KYC check function. So if self dot validate username and self dot validate PAN, and 1 minute. I did not write what username, right? It has to be like that. Username. I should write PAN here. And here I should write address. Self.validate address. Yeah. Print KYC verification successful. KYC verification successful only when it returns true. That is what I'm just telling line by line what I'm doing. Else print KYC verification failed. Simple. KYC verification failed. Please verify your details again. Okay. And this should be the case when it returns false. Even if one of these scenarios are not fulfilled, it will return false because I have put and. If I would have put or, then it would have given me true. If I would have put or and I would have given at least one condition true, then it would have returned true and it would have said KYC verification successful. As simple as that. Then afterwards, I have defined all this well and good, but we are still not done yet. We want the username that the customer will give to be encrypted, right? So we have to define some encryption functions also. It's not just limited to us creating the private key, right? So now let's do define encrypted data. Self data, right? And then encrypted data. Actually, I'll just write encrypt here. Encrypted data should be equal to self dot cipher RSA, cipher underscore RSA, because actually my bad, I didn't name it here. Self dot cipher underscore RSA. There should be a self dot cipher underscore RSA here. So self dot cipher underscore RSA bracket data dot encode. Okay. So this is what will, this means that we are encrypting the data. But remember, we should also hexlify the data. So what this will do is, it will encrypt the data using the cipher that we are initiating here at the instance level, right? It will convert it into UTF-8 bytes. Okay, that format. But then we also have to hexlify it. So now if we want to initiate a encryption, we would have to do some initiation using self.cipher RSA as I've defined here. Here, self.cipher RSA. That's the whole purpose of defining it at the instance level, so that I can put it down here and encrypt the data. That's it. But now when we do data or encode is for converting into UTF-8 format, right? UTF-8 bytes, which is not readable at all. If you Google it, you'll figure out it's not human readable at all, and it's not considered good for storage purposes. And converting and you cannot really convert a data into a string using UTF-8, stuff like that. So there are issues with that. So let's convert it into hexlified format first and then convert it into a string. Okay, so return binasky. That's where we use this library, binasky. Binasky dot hexlify encrypted data. This encrypted data that I just defined, encrypted data dot decode. So this is, now you'll ask me what is decode for? Are we decrypting here? No, we're not decrypting here. This is for converting this this hexadecimal format into this string format, so that it is like readable for for humans, right? And good for storage purposes. So 2-digit hexadecimal format to string. Okay, that's the whole purpose. So now what I'm doing is I'm going to decrypt the data, just the same process as encrypting. Only thing is I'm reversing it. So of course the bank would have to decrypt the data, but it has to be run via authorized set of individuals, like who are trustworthy and who will ensure that this happens very safely. Customer data is safe. So what I'm taking is, again I'm using cipher RSA for the same. Binasky, hexlify and data.encode. So I'm just converting the string. You remember that I had converted this into a string. I'm just converting that string into encoded format and then actually it's unhexlify, sorry, unhexlifying it, and then that is done using cipher RSA. That's what I'm doing here, as simple as that. Then I'm returning it in the string format. So for that I will just do return decrypted data dot decode. Decode is for converting into a string format. This is simple. That's it. We are done with the encryption decryption successfully. Now now it's time to define these username, PAN, address, overdraft limit, and so on, right? Let's get to it. Let's get back to that level. So if now I have the KYC done also, so I can easily define a function accordingly. Yeah. So if self.kyc check, this KYC check I'm using, okay. If self.kyc check username, PAN, address, that means after the check has been done, we will encrypt the data successfully. Okay, that is what I'm going to initiate. So self username is equal to self dot encrypt data. Sorry, because I wrote encrypt data here, I'm just using it here, encrypt data, and then in the bracket put whatever data you want to put, right? Here I'm going to put username, whatever customer username I get. Then self dot pan is equal to self dot encrypt data pan. Similarly, self dot address is equal to self dot encrypt data address. Then self dot balance, because I want to define what balance also the customer has. I have not included the balance here because clearly it's not necessary to include it there. It's something that the bank will take a note of, and look at how I'm going to define it, so don't worry. Self dot encrypt balance. Okay, now the problem is that I have not put the balance here in this bracket. Okay, I have not put the balance here. The balance is going to be a float. Float object can't directly be encrypted like that. I would have to separately define it. Okay, I mean it has to be separately defined so that I can convert it into a string first and then hexlify and do the respective encryption process. So I have to separately define it. So I will go here, define encrypt balance, self balance. All right, then I will go encrypted balance is equal to self dot cipher underscore RSA dot encrypt string balance dot encode. Okay, what I did here, whatever balance I am going to input here, it's going to be 0, 0.0, but whatever it is, I'll convert it into a string and then convert it into UTF-8 format, bytes format, right? So I'll just take a note of it here, converting into a string and then into UTF-8 bytes format. Then afterwards, return encrypted balance dot hexlify. Now I can hexlify it, but I'll have to use binasky library, sorry. Return binasky, my bad. Return binasky dot hexlify bracket encrypted balance dot decode. Decode is always necessary for converting it into a string, regardless of you encrypting or not. Then define decrypt balance self balance, again same thing. Now this is the normal procedure what I did for the decrypt data thing. Decrypted balance I'll define here is equal to self.cipher underscore RSA dot decrypt binasky dot unhexlify, then balance dot encode, right? Why am I writing balance dot encode here? You will ask me, you wrote data, why balance here? Because I've written balance here. I'm doing it specifically for the balance. So balance dot encode. Then return float. When I'm decrypting it, obviously I don't want it into a string format, right? I would want it back into the normal number format. The bank would want the balance in the normal number format. Suppose it's a 10,000 amount, they wouldn't want it in the encrypted format. They would not understand what is a string format for 10,000. What would it be, right? So we would have to convert it into a float first, then write decrypted balance, that decrypted version of it, where it is unhexlified and from the UTF-8 and so on, dot decode. Decode is again to convert into string. This is necessary. This is not that string which I'm talking. This is necessary for storage purposes and for visual human reading purposes. This is not the string that would lead to the float getting converted into a string. So there's a difference here. That's it. I'm done, I think. Now I'll just go back here. Self.encrypt balance. Now that I've defined what is encrypt balance, I'll go here and write it down. Self.encrypt balance. Self.encrypt balance. How much would the balance be? I would just write it as 0.0 because it's a float. Yeah, I took it as a float object. Then similarly, I want to define overdraft limit as I've already written here. Again, it's not necessary because I've already written 0.0 here, but you can just write self.overdraft underscore limit is equal to overdraft limit. Like, what I've already defined, I'm just bringing it down here, this one, right? So, that's pretty much it. Then I wrote an if condition, but what would I want to return? What if what? If this is all the encrypted version is fulfilling the KYC check, the encrypted version of the customer details is fulfilling the KYC check, then I will print hello, f string hello, because it would be more easier then, f string hello self dot decrypt data bracket self dot self dot decrypt data, but which data? Self dot username. So what I'm doing here is, you will again ask questions. I am taking the decrypted version of the username. So of course, when I have to print if Haya is in encrypted format, of course you would have to bring on the decrypt function so that I can get Haya back to the original format, that is Haya, right, from encrypted to decrypted. So that's why I'm writing self.decrypt data bracket self.username. Simple. this is like that. Again, I'm sorry, this is correct. Yeah, congratulations, your account has been created. Right? Perfect. Now, of course, when if is there, else will also be there. Else has to be in the same indentation as the if is, same line as if is. So else, raise value error, KYC verification has failed. Please check into your details. Please check into your details and try again. So what I'm doing is, I'll just raise this error in case if it will raise a value error in the output that your KYC has failed, verification process has failed. Okay, well and good. That's all about how, for now, that's all about it. Let me just ensure that this is running. Okay, doesn't seem like there's a mistake in it. Well and good. Now I'll just show you a mini version of how this would be done, how the customer would create his account. Okay, now I have not put deposit, withdrawal, all of those functions yet. I'll do it later, but just look into how the account will be created. So first I'll write input, enter your name. This input function is used for ensuring that the customer is giving the, like in the output, he would be given the chance to enter his name. Input, enter your name. So tell me, the customer, what is your name, your PAN card, your address respectively. So input is used for that. Enter your PAN card number, address is equal to input, enter your address, and then B is equal to bank. Yeah, now what I'm gonna do is, I would ask these details from the customer, but how will the bank, this entire thing, the operation, the object-oriented programming we created, how will that be initiated in this? How will encryption take place? How will bank take the details and store in their system? So for that purpose, we are going to define B is equal to bank. We are calling this class. This entire class is this entire thing we created basically. We'll call the bank class and we'll put username, PAN, address. Okay, because mainly we have asked these details. Overdraft is already defined. We don't care. It has nothing to do with the customer. It is something about the bank. But username, PAN, address is what the customer would be concerned with. Right? So let's try it. I'll write my name. Okay, I'm just going to try with one name. Let's see if it accepts. A, B, C, D, E, 1, 2, 3, 4. Because I'm doing according to the format that is defined here. Then A. Okay, there's a problem. Just a minute. We have initiated this. We have done. Okay, now let's try it out. Hiya, A, B, C, D, E, 1, 2, 3, 4, N. Okay, SLL. Okay, KYC verification successful, but there is a problem here, and it is coming from encrypted data. Okay, so what mistake I did here is, I did not write .encrypt here, right? So I purposefully made this mistake so that you guys can understand why it is important and how normally mistakes can happen. Similarly, for this also I have not written .decrypt. So until I don't mention these, how will the encryption and decryption take place? So this is one thing that has to be taken a note of, right? Let's try again. Hiya, A, B, C, D, E, 1, 2, 3, 4, N, SLL. Okay, so my KYC verification is successful and my account has been created. That's it. Well and good. But if I would not have fulfilled the criteria, how it would have shown an error for me? Let me show you. Hiya, A, B, C, D, 1, 2, 3. This is not the actual format for the Indian PAN card as defined here. Then address SLL, just randomly. So it failed because my details are not correct. My detail for the PAN card is not correct. I told you here that even if one of them is incorrect, even if one of them is not validated, it won't be able to show you a successful KYC verification, and therefore it has raised a value error because I raised the value error here, that raise value error, KYC verification has failed. That's what it's doing here. Okay, well and good. Now let's put some more deposit, withdrawal, closing, breaking, such kind of functions, so that it would sound like a proper bank functioning code, you know. So what would we do for the same? Now we'll come here. Okay, we'll write define deposit. Define deposit self comma amount. I would describe the amount here actually. I mean, yeah, the amount would be described somewhere here inside. So if I put a condition, if amount is more than 0, current balance is equal to self dot decrypt. I mean, of course, the amount that would be deposited will be more than 0, but this is just, you know, sometimes if by mistakenly, if any errors occur, by mistakenly you put a minus amount, bank subtracts the amount or something like that. So negative amount, to avoid all of that, we are doing this amount more than 0. Self dot decrypt underscore balance, self dot balance. I have defined the balance here, right? This only I'm using here, and it will be in the decrypted format, so that decrypted format as I've defined here, so that the bank can deposit it. The bank should be able to see what is a decrypted balance, right? Until they don't see 10,000 or the particular amount that the customer wants to deposit, how will they perform their activities? So for that purpose, we'll write self.decrypt balance. We'll have to get a decrypted format. Then new underscore balance is equal to current balance plus the amount that has been deposited, right? Of course, we are updating it in the form of new balance. Self dot balance is then equal to self dot encrypt. Okay, encrypt balance, new balance. Now, what we are doing here is we are updating the balance and then we are encrypting it. While depositing, the bank would have to get in the decrypted format, but while in finalizing the entire process, they would have to encrypt it, right? So that it's safe. Nobody else gets to see it. Any random employee who is not authorized to do the same will not get to see the balance and, you know, like do some wrong stuff, you know, with the, like, you know, take away the money basically. Lol. So print f string. I would like to print something at last. Print f string amount. Whenever you use f string, just remember there are curly brackets involved. F string amount deposited successfully. So we are just informing the customer, raising the notification that okay, your job is done successfully, you're good to go. However, if the condition is not fulfilled, that is if the amount seems to be negative, less than 0 or something like that, which is highly unlikely, but you know, sometimes mistakes can happen, print invalid deposit amount. Okay, now time to define the withdrawal function. Okay, so it's pretty much similar. Only thing is now we'll check it if we have enough balance to make the withdrawal or not. So current balance again is equal to self.decrypt. We'll have to decrypt the balance so that the bank can see, right, what it is. And again, now we have to put a condition, if condition. So if self.balance is more than or equal to amount, or self.balance plus overdraft limit, because we have defined self.overdraft limit, actually self.overdraft limit is more than or equal to amount. Okay, so I'm sorry, I put a wrong sign here, is equal to. So here what we are doing is we are checking it's our current balance is more than equal to amount, or current balance plus the overdraft limit is more than equal to amount. Okay, so we are giving room to both of these basically, right? It's according to the bank. If the bank does not have overdraft limit, they can cancel this line. they can just keep this one. But if they do have, then keep both of them, or just keep this particular one. That's the main thing. Every bank has a overdraft balance, of course, so they will keep this line, but I'm just keeping it for safety. I'm keeping or means any of these will work according to the situation. So new balance is equal to current balance minus amount. Okay, so it will initiate the transaction only if this is more than or equal to the balance is more than or equal to the amount that is going to be withdrawn. Of course, that's normal banking, right? There's nothing harsh in this to understand. Self.balance, self.encrypt. Now our updated balance we are going to encrypt for safety. So new balance, same procedure that we followed here, new balance. Okay, and then we'll also print f string. I'm just going to copy this thing, Control Z again. I'm going to print it here. F string amount is string amount withdrawn successfully. Okay, well and good. Now of course I put in an if condition, I would have to put an else condition. Else print that you have got insufficient funds for the same. So print insufficient funds. Insufficient funds. Okay, so insufficient funds, and here again I put an if here, so I will have to put an else also for this, consecutive else for this. So else print invalid withdrawal account, because of course if that's highly unlikely, but if there's a negative amount by mistakenly input by the customer, then we would write invalid withdrawal amount, right? Simple. This is all about it. This is how we are doing it. Now I also want to import some more functions, like I want the customer to get a mini bank statement also if he wants to see the final balance that he has got, after all his transactions. So I would define bank statement self. Okay, this is just going to print the final balance, like after all the withdrawals and stuff. So I don't have to write balance here for that purpose. I'll just print out the self.balance which I'm getting from whatever he does. You will understand how whatever transaction he makes. You'll understand it when I initiate this thing in the upcoming code. Don't worry. So define bank statement. If just print it out. F string your account balance is self.decrypt balance bracket self.balance, because of course we need to give the decrypted version, then only they'll understand it, right? And then close the bracket. Sorry, my bad. And we are good to go. Fine, we are done. I think this is all I want. I have deposit, withdraw, bank statement, I have encryption, decryption, I have KYC procedure. Everything has been initiated. Well and good. Now how will I use it? Okay, there's a problem in else statement. Okay, f string amount deposited. Oh, my bad, I did not close it. That's why this happens sometimes. Withdrawn successfully. F string oh, I did the same mistake here. Yeah, of course, I copied from here, right? If amount is more than 0, yeah, always after if, that has to be there. I forgot about that. Yeah, now we are good to go, I think. Why is it showing this else print? So let's see if it's correct. I think the indentation issues are already there, so I'll just do one thing. I'll do a tab so that it's safe. I don't know. Let's see if there's an error that's occurring. Yeah, I don't think it should be that way. 67 should be there. So now I have defined all the functions. There was some error, I corrected it, don't worry. The small minor errors like, you know, colon, if, and so stuff, those stuff are not there. It happens. It's pretty basic. Now okay, so do you guys want to check the the encrypted version of the username, because that would be interesting to check out. So let's just initiate a function, initiate a code for that, checking encrypted values. So I would say print username, print encrypted underscore username. Sorry, why am I putting underscore here? Username, just like that, and then b dot username. Why b dot username? Because I've initiated this. I'm just calling b dot username. Similarly, I will call print encrypted. Oh, the spelling. Encrypted username, encrypted pan, b dot pan, and then encrypted address, because the customer's address should not be like visible. So b dot address, right? B dot address. Well and good. Let's try it out. So maybe it has just stopped working. So I'll just restart the kernel, you know, and I'll again run the code. Okay, hiya ABCDE 1 2 3 4 N SLL simply I wrote. Yes, there we go. So I got the encrypted username, encrypted pan, encrypted address. These are all what I had input, and these are all the encrypted version of what I put, right? Now, of course, to perform the functions, to perform their responsibilities, their activities, the bank would have to decrypt these. It is important, but it is also important that authorized individuals are already decrypting these, right? Stuff like that. Now, if I would want to decrypt the username, you know, suppose for example, I have defined decrypt function. I can just use that. I know it's right there. Like everything is right there. It's already there. But I want to use a decrypt function which I have defined here and use and find out. Okay. So what will I do? I will simply just say encrypted username is equal to b dot username. Okay. Well and good. And print decrypted username. Why am I putting this? Username like that. Decrypted username would be b dot decrypt data. I'm just using the function that I defined above, nothing else. And encrypted username here, this one put here. Well and good. Okay, let's try. Hiya ABCDE 1 2 3 4 and SLL. Okay, so here we see our respective encrypted username. It has decrypted it. So hiya, it has been brought back using the decrypt data function. Sorry, here decrypt data function properly. Well and good. Okay, now I got all this well and good. Let's just turn it into hash. So now I want, as I said, how will now the customer has created the account, well and good. How will he do the depositing, withdrawal, all of the regular activities that he wants to use the bank for? Okay, I need to create some function. I need to create some coding. I need to do some coding for that. That's what I'm gonna do now. So we have seen the encrypted values. I'm just gonna hash them so that, you know, like, just don't want to use them anymore. Then I'll just try infinite loop I'm going to create. So while true, print slash n, because I'm just going to leave a line. Please select an option. Okay, like that, and then print one dot deposit. Okay, slash n, front slash n is for bringing going to next line. So 2 dot withdraw, this withdraw will go in the next line, okay? Then slash n again to bring it in the third line. Third is a mini bank statement, and finally close. Fourth is close. That's it. Okay. So I've given the options. I've given 3, 2, 1, whatever. But okay. Now I'll define what option, what it will be. What will this option? How will the customer input it? So I'll write input whatever value he wants to give. However, if he gives something like a float, like 3.4 or 5.5 or something like that, for that purpose I need to ensure it's an integer. So that's why I'm like, going to write integer so that he gives the correct number in the correct format as given here, right? 3, 4, whatever. So if option is equal to 1, amount is equal to float, input, enter deposit amount. Okay. Then similarly b dot deposit amount. Okay. Now you'll ask me, what is b dot deposit for? B is what we called here. B is like the entire thing. We are calling this entire thing that we wrote here, right? And from this B, I'm getting the deposit. I defined a deposit, right? I'm just getting that. Simple. First option is deposit. I'm just calling the deposit here. That's it. So it will do the entire procedure as per what I have defined here. Simple. Then afterwards, else if option is equal to 2, I will go for amount is equal to float, input, enter 1 minute. I would have to ask a question. It has to be in string. Enter deposit amount. So now again, I would just say that, okay, give me deposit amount, but it can be in float format also. Here, 1 minute. I'm so sorry. This was a deposit amount. Second option is withdrawal. Yeah. So if it's withdrawal, again, it can be in float, it can be in decimals. So I'm just gonna call b dot withdrawal, withdraw, and amount. Okay, because we have to call the amount here in the bracket. I've defined it. So b dot withdraw amount, whatever amount he'll give here in the decimal format also, it will work, no worries. Then else if option is equal to 3, that again I'll just simply call b dot bank statement like that, because this is what I've defined here. I'll just call this b dot bank statement. Okay, that's all. And then afterwards, else if option is equal to 4. Okay, print thanks for using Axis Bank. Okay, thanks for using Axis Bank with an exclamation, and break, because I want to break the loop. Okay, it will keep running and running and running. It will keep asking the customer this again and again. So I'll just break this loop, because when he selects 4, the loop will be broken. Otherwise, it will keep asking. I'll show you how it works. So else print invalid option. Yeah, so there has to be room for some invalid option too. So invalid option, please select a valid option, because sometimes what happens is that besides these 1, 2, 3, 4, they might end up selecting 5, 6 or whatever. So for that purpose, I'm writing else print. These else if is something that's supporting this if, like it's like paired with it. But else, when this comes separately, it's like if otherwise this, alternative to if, otherwise if not this, then this, like that. So else is also necessary condition, with always goes with if. So print invalid option, like that, stuff like that. Now since I wrote try, always with try there's another thing that comes consecutive to it, that is except value error as e, print e. So if there's any sort of value error, any other error that I've not taken an account of, that we do not know, it will get printed accordingly. Well and good. Okay, so I think we are done. We are done giving the options. Let's find out. Haya, A, B, C, D, E, 1, 2, 3, 4, N, SLL, whatever you can give here. Okay, now it's telling my account has been created and it's going to give me one of the options. I will take one. Enter deposit amount 10,000. Okay, has been deposited successfully. Now I want to withdraw. I want to withdraw 15,000. Okay, it will say invalid option. Okay, I need to restart the kernel because again it's just not running. This and this. Okay, now Haya, A, B, C, D, E, 1, 2, 3, 4, N, SLL. Okay, I want 1, 15,000. I want 2. I want to withdraw. Oh, 1 minute. Why is it showing deposit amount? Because oh my god, what's wrong with me? Enter withdrawal amount, not deposit. Withdrawal amount. It should be, so I'll write an amount which is more than the deposit amount, so 20,000. Insufficient funds. Yeah, it's showing this message because I have written insufficient funds here, that's why. Then now I want a mini statement. Your account balance is 15,000. Why? Because it did not do the previous transaction, it did not run it because of insufficient funds, so it will remain up to the amount that has already been there, the deposited amount, that is 15,000. Okay, well and good, fine. Now I'm done with this main process. I think we are good to go. I showed you encryption, I showed you how the bank works, I showed you all of those. What about doing some MPC, secret sharing? So multi-party computation is where I told you once that I'll show. Okay, wait 1 minute. I didn't print the private key. Why has the private key not been printed? Self or private key. Private key has some problem. Is there? It should be printing actually. I don't know. It's taking time or what it is. Initially, I had printed it out. Print private key. What if I try it here? No, I don't want to try it there. So earlier I told you that I want to print the private key, right? It should not be disclosed to any party. So, but it can stay in an isolated environment with many parties, with many authorized parties. However, not in its original format. That is what multi-party computation helps in doing. Now there is some code for that purpose. There is some secret sharing code, how that private key secret will be shared. Okay, so for that purpose, first I would avoid doing it here because I don't think it prints it out if I do it at the instance level. So I'll print it here instead. I'll print the private key from here instead. So like that. Let me see if it gets printed out. Don't know if it will because again I think the kernel stopped running. So I'll restart. I'll do this. It should give me by now. Yes, it gave me. Yeah, that's what I'm talking about. This is the private key. So our entire information that we have used, that we have encrypted, has been done via this private key. We can only decrypt the entire information via this private key. It has to be kept very safely. It cannot be just disclosed merely to anybody except if authorization and authenticity is there in the hands of the respective human who is utilizing, who is dealing with the funds and all of that, all the customer sensitive details, right? So just ensure that this is safe. That's all. Now, how will multi-party computation ensure that it is in the hands of authorized parties without them really revealing the information to each other? For that purpose, we will just do a simple thing. We will convert this into numeric format such that it can be divided into different shares of information right? And when required, this key will be this key will be formulated by summing up those shares. So basically what I'm saying is I'm converting this into a numeric format and dividing into many shares, and then I'm going to sum up those shares to get it back into its original format, that is this. Okay, so let me show you with some more context. With you won't understand it like this. Wait. So there are different shares. Okay, there's a private key. Okay, there's a private key which I just showed you guys. I'm going to convert that into a number, a number which is like quite complex, quite hard to break and stuff like that, not quite hard to predict. Then I'm going to divide this number into different shares, and these shares will be handled by different parties. Simple. Okay, and then when the bank would want this private key back, they will be like, hello, give me the private key, I want to decrypt some information. These parties will compute and sum up the shares in such a way such that it will come back to its numeric form and then to the private key form. Convert back to the private key format. Reconstruct back to the private key. This is what multi-party computation is. So none of the parties know exactly what they have with them. I mean, they do know that there is a private key, but they do not know the actual version of it. They just know the numerical version of it. So clearly it's like randomized, it's done through randomized numericals. And after that, it's converted into different shares of different numbers. Okay, so that's how MPC works. And these parties, of course, like there are risks like the parties colluding and formulating, going against the bank, probably like decrypting the private key and stuff like that. Something, or all the three parties can do this thing. Actually, there can be more than three, but I'm just telling there can be stuff like colluding. So banks should maybe probably just make some agreements with them in prior for ensuring that they do not get into any such thing, and if they do, then there could be some repercussions which they would have to pay penalties for. Okay, or they could just incentivize them for performing the computation and reconstructing it back. They could incentivize them in a way such that they would not be encouraged to do any fraudulent activity, because until and unless they have the key, I mean in the form of different shares, until and unless they are ready to do the computation, they will be paid. But soon after they leave this, they leave the agreement, they leave the computation process, the payment will be stopped. So because of that, they would be encouraged to be associated with this and get paid, right? So that's one way, that's another way to ensure that they do not get into collusion and any fraudulent activity and decrypt the private key as a result, right? So these are some measures that we can take. I mean, every day there are risks involved in variety of things. We cannot just just keep finding out the most perfect thing on earth which is without any risks, right? So even this is one of them. Now let's start with how exactly I'm going to do it in Python. So first I'll create some libraries. I'll import some libraries which are necessary for this process. Okay, cryptographic libraries. And here we will be using Shemi's secret sharing scheme. So if you want to Google about it, you can. So whatever he has suggested, whatever processes, whatever libraries are associated with his process, everything will be used here for the same, for doing the multi-party computation, for actually finding out how can we convert this private key into numeric format and then into shares. I'm not doing the reconstruction part. I'm just finding out how will be converted into different shares, and that's pretty much it. From cryptography .hazmat .backends, import default backend. From cryptography.hazmat. No, these are just cryptographic libraries that will help to perform this process, as I already said. Okay, import serialization. Okay, this will be used later for performing the converting it into a numeric format, the private key. So I'll show you how this will take place, but yeah, I'm just telling what the library is for. Then import random, and from typing library import tuple. Okay, again I'll tell you why it is used, but let's just stick to this. No module name cryptography. Okay, spelling is wrong, lol. Okay, that's pretty much it. So then field size is equal to I'll start with this. I'll tell you what it is. 10 power 9 plus 7 large prime number. So usually for cryptographic operations we use a large prime number like this. You can search more about this. We use it for doing the modulus. Okay, modulus is what? We are finding the remainder. Like modulus is ensuring that when we divide something, we get the remainder, and this type of modulus will ensure that this remainder is in a finite format. Okay, that means whatever ranges we are dealing with, I'll show you how exactly it works. It just ensures that it's in a finite format. So define coefficient t integer, okay, comma secret. So I'm defining two variables inside it, okay, and then I'm going to convert it into a list. I want the answer in a list. Okay, basically we are going to use a polynomial function. So for that purpose I'm going to generate coefficients. This is the step that I'm doing right now. So coefficient is equal to square bracket random dot randrange, okay, field size, okay, for underscore in range t minus 1. Okay, so this is the step for generating random coefficients, but in a finite range. Okay, finite range means like it's not that I need like infinity number of coefficients, right? I just need it in a finite range where somewhere at least it will stop the generation process. It can't just keep going and going and going and going. Okay, I need the process to stop. So that's why I'm just generating random coefficients, but in a finite range. That is the field that is decided by the field size. That's why I'm putting the field size. Okay, you can search about this field size more. Usually this prime number is actually it's simple. There are more complex prime numbers, but just for simplicity I've taken this one. Okay, so this is what I'm taking. Okay, then after that we have to take coefficients. I just define the variable. Now I'm going to append it and add secret. Okay, so this secret is going to be the last coefficient. I would not say coefficient, it's going to be a constant variable. Okay, but it's not going to be with any x1 and y1 value. It's just going to be added at last as a constant variable. You know, ax plus b, b is a constant variable, or I'll just say 1 minute. Usually when we write x square plus x plus 1, that 1 is the secret. That is what it is doing. Okay, so coefficient of append, we'll add the secret like that, and then afterwards return coefficient, because of course we have to return the coefficient. So this was the process of generating the list of coefficients. Again, the square brackets represent the list. Okay, then define the generate shares process. Before you ask me what is t minus 1, t minus 1 is just that it would define the degree of the polynomial. What is the degree of the polynomial? So as I just said, x square plus x, this 2 is the degree of the polynomial. Okay, but it's going to be in the list of 2 minus 1. Basically it's going to be in the range of t minus 1. Why? Because the last one we are going to add as a secret. The last coefficient has to be the secret. That's why we are adding it this way. We are doing t minus 1. This is y-axis, this is x-axis. There will be different x1, xy, xy, you know, this is just one random I'm generating. So these will be the shares. These will be the shares, x1, y1, x2, y2, and so on, xi and xi, where is it? Yeah, xi, yi will be, yeah, like that. It will keep on going. It will keep on generating several shares. Okay. So that's what we are going to generate right now. We are going to define a function for that right now. Okay. Now what should come in the brackets? In the brackets, we should define what exactly the integers will be involved, what integers and stuff will be involved, you know, like what number will be involved. So n will take integer, m will take integer. I'll explain you why exactly this is happening. List and like that. Okay, so what we are doing here is, I'll tell you why I'm taking n, but for now let's focus on m. Okay, so I'm going to define a function coefficients. I'm going to create that. In that I'll take this list of coefficients that I just made, right? This list I told you. From that I will take I'll just import that here, coefficients, then bracket m secret. So here m is the one, I have replaced this t by m. Okay, and secret is secret as it is. Whatever that private key will be my secret, that only I'm writing here. Later I'll define what that, later I'll write secret is equal to private key serialization and all that. Okay, that's like later. But what I'm doing is, whatever I have written here, whatever I have defined here, I'm just writing it down here. As simple as that. So coefficient m secret. Okay, and then afterwards we will write basically m here is the number of parties that would be involved with the sharing process, with the creation of these shares, you know, with the creation and computation of these shares, and with the reconstruction back to the private key and stuff. So these would be the number of parties, m would be the number of parties. So what does that mean? Basically the degree of polynomial will, that is t minus 1, or we can just say that t that I used for in the definition of coefficient, that is deciding by number of parties that would be involved in the secret sharing process. Okay, now shares, let's initiate a list shares like that, and then for I in range 1 comma n plus 1. Okay, so basically I don't want any x value to be in range 0 to n. Basically you guys will say, why is she doing n plus 1, why is she starting from 1? Basically, you know, in the last the indexation, how does the indexation work in Python? 0, 1, 2, 3 and n. Okay, actually no, you'll get confused. 0, 1, 2, 3, 4. So if I am creating if I want a list, or sorry, if I want a range from 0 to 4, it will take 0, it will take 1, it will take 2 and 3, but it won't take the last one. So that's what it's doing. I want up to n, and I don't want 0, but I want it to start from 1, because I don't want my x coordinate to be 0, because if x coordinate will be 0, then my secret will be revealed. Okay, why am I saying this is because suppose this is my equation, polynomial equation, and if I put f of x Okay, this is my polynomial equation. So f of x, if I put as f of 0, you know, it's back to algebraic mathematics, where you know, we used to input all those values in x and stuff like that, no? So it's just I'm just doing that. That's what is applied here. So 0 square plus 0, okay, that would be 0. But then 1, I said 1 is my secret, right? So 1 would be revealed. So if anybody puts 0, any hacker puts 0, he'll get the secret value, he'll get the private key value, right? I don't want that to happen. That is why I'm not including the 0 here in this range. Okay, that's as simple as that. So x is equal to random dot rand range. Okay, 1 comma the field size. Now this n plus 1, I don't want it to, like, you know, be an infinite thing. I don't want x values to be generated like forever. I just want it to end somewhere, right? That is why I'm taking this field size. That is a finite limit right there. Okay, that's all I'm doing. So then this is the field size, and then we are generating, let me write a hash for this, generating random value for x. Okay, yeah, random values for x. After that, I will just write shares dot append x comma polynomial x comma coefficients. Okay, now you will ask me, what is this? This is basically the x and y. Okay, so when we say x and y coordinate, what is f of x basically? F of x is basically y. Okay, so all I'm doing is, from the given value of x, I'm generating y values. Okay, so if I get f of x, that means I get my y's. I'll just keep adding them in the shares list: x1, y1, x2, y2, x3, y3, and so on till the finite number ends, till the finite range, as I already defined, right? So I'm just writing my x and y values. Now you will ask me where this polynomial came from. I will define this function, don't worry. I will define what is polynomial, because Python doesn't know that. Python just knows that basically whatever we are giving to Python, it will just interpret that and print that out. Okay, we wrote what is x, it will print that out. We wrote what is coefficients, it will print that out. But it will ask me what is polynomial, because I have not defined it yet, and it doesn't know on its own, right? We have to define and give it to him. So that's why I'll do it in the next step. Just wait for that. Okay, so return shares, and then now I'll come to define polynomial. Okay, x integer coefficients list. Okay, so now I've got a list of coefficients, right? I imported the list of coefficients from here to here. Okay, then I have defined it as list here. Remember that I defined n, m, secret, everything as a list here. Basically, I'm going to get a list of coefficients. In layman's language, that's what it means. I'm going to get a list of coefficients, right? It's not going to be 1 or 2 items alone. It's going to be a list of coefficients. So that's what I'm doing. And basically, I've just imported the coefficients from here. And initially, it was a list. So that's why I'm writing it as a list here again, because I have got the coefficients defined and I have used COEFF from there. That's what I mean. Oh God. Then afterwards, x integer coefficients list. The entire thing should be integer. Okay. Again, I'll tell you why it is so. Initially, the y value will be 0, because that's just initially it's gonna be like that. For coefficients see, y values are free to be anything. It's just the main thing is the x values. Okay, x values cannot be 0, otherwise the secret will be revealed. Okay, so for coefficients, in coefficients -1, okay, we will take y is equal to y into x plus coefficients. It's just a basic polynomial, y is equal to ax plus b, okay, or it's just similar to that, nothing much, where coefficient is a constant, okay, and we have got it from the list of coefficients. Now I know you have questions in your mind, but wait, just wait for me to complete the code. Field size, return y. Okay, so what we are doing here is we are defining the polynomial function, we are telling what the equation is, and for coefficients, I'm sorry about this mistake, it might have confused you a lot. For coefficients in coefficients, okay, so now I've got this list of coefficients from here, right? I've got it from here, I've written it here. We got coefficients in coefficients, so this one is from the list of coefficients that is coming from here, and in turn which is coming from here, okay. So before you get confused, before you think what is this coefficient she's talking about, this coefficients has come from here, whatever random range we have generated na, that only we are bringing down here, okay. Then only we can find out the polynomial function and the y values, right, once we bring the coefficients from here. Now you just follow the process and see how exactly it is done. For coefficients in coefficients, list of coefficients, this minus 1, okay. Now you'll ask me what is this. It is all about indexing. So in Python we know 1 2 3 4 0 1 2 3 4, okay. That means it's a list of 0 to 3. It is, that's how the indexing will be done for this. 0 1 2 3 4, 0 to 3, because we never include the last value, okay. That's how indexation is done. Now if I want from the starting value, I would have to do it as 0, like that, okay. So basically what it means, if I want 1 2 3 4 5, if I want all the elements, I'll write zero, like that. If I want from 5 to 1, I'll write dot 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 minus 1, right? What I just did here, I wrote this minus 1. So basically I'm saying that it is going, the sequence is going to start from last to first, okay, as simple as that. So this is all about it. Now you're telling, yeah, so now you're going to ask why exactly are we doing from last to first. That's because in Horner's method, we're using Horner's method for polynomial. So for that purpose, he is asked to use, for optimal performance, we have to ensure that the coefficients are going in a descending order, okay. So suppose if it's coefficient is 1x, sorry, coefficient is 1 2 3 4, it should start from 4 3 2 1, you know, for, you know, efficient performance and stuff like that. So that's why we are reversing the order of the coefficients that we got from here, okay, simple. Now we got y value also, we define the polynomial also. For now we are good to go, okay. Now that's it, this is the shares generating process, okay. This is the shares generating process. So now it's time for loading the private key, okay. So let's do it. Let me write it down. Hashtag loading the private key from the PEM encoded string. It's just basically PEM encoder is the format in which we usually store the private key. It's just that, it's just telling that the RSA generated private key. Actually, this as I told, RSA is the library that we use. RSA has helped us to generate the private key also. That only whatever format is generated by RSA is referred to as a PEM encoded one. Okay, now private key is equal to serialization. That's where we use serialization dot load underscore PEM dot private key. Okay, and then we will load our private key. So I will just go here and copy this entirely. Sorry, my bad, by mistakenly. Yeah, we are done. We just pasted it like that. Password is equal to none. Okay, for now we are not setting any password. Should write capital so that that's the Python function. Backend is equal to default underscore backend. Okay, did I do a mistake or something? 1 minute. Yeah, I think I should not close the bracket for this. Yeah, so comma here and then close it here, because like it's one function, it's all a part of this. You should just add a comma and yeah, like password right now we are setting none, but the bank should set some password for accessing. Okay, and then convert the private key that we just stored to a numerical value. So as I already told, we are going to convert into a numerical value for sure, and for that purpose we will convert it into an integer. Okay, so you can numerical format like that, and then secret. Okay, secret as I already defined here. Now it's time to actually use it. Okay, so secret is equal to integer dot from bytes private key dot private bytes. Okay, this is how the code is. Private key dot private bytes. Okay, this is converting. Okay, private key dot private bytes, but the bracket is not closed here because there's more to come in this. Encoding, under this we'll write encoding is equal to serialization dot encoding dot der. So this is a digital communication protocol that is going to take place between different parties for converting into a numerical format, performing the computations and stuff. So for that purpose, this encoding is taking place. This encoding full form is distinguished encoded rules, distinguished encoding rules. So I'll just write it down here, distinguished encoding rules, and it is used in digital communication protocol. Okay, distinguished communication protocol, like that. Format is equal to serialization dot private format. Okay, dot pkcs8. Okay, that's usually the method that's used. That's the key, actually. This one, pkcs8, and then we'll write it as standard for storing the private key. And then encryption algorithm should be no encryption. That's basically like we are not ensuring that there's any encrypted process involved, because see, we directly want to convert it from the plain text format to a numeric format. We don't want any encryption involved yet. We'll just add to complexities. Like, we don't want this private key to be converted in encrypted format and then to a numeric format. That would just make it complex, because when you would have to convert it back to the private key, when the bank would ask for the original private key, which is this, you would first have to get the numbers from the shares from the different parties. Okay, then afterwards you would have to convert it into the encrypted format, then decrypt it, then get the original format. Of course, after decrypting we'll get the original format. So that would just add complexities, simply make the entire process very complex. So it's better that you just keep it simple. You don't have to create a fuss over here, and it's not suggested by experts also. So let's just create serialization dot no encryption. Okay, like that. Sorry about the spelling. No encryption. Okay, the bytes, these bytes, right, will be in plain text while serialization is conducted. I'll just write it down. Then afterwards we close the bracket. We close the bracket. We write byte order. We write as byte order is equal to big. Okay, so here we are defining the sequence of the order, basically the sequence of the bytes. The bytes is a format in which the private key has been stored. Actually, it's in numeric format, but I'm saying that this format is bytes. We are going to ensure that the most significant byte will come in the beginning of the sequence. Like, it's going to be like in a descending order, like big to small. That's why we are writing byte order is equal to big. Okay, there's some problem with the brackets. This is for this. Okay, wait, integer from bytes, private bytes. I lost track of this bracket. Yeah, that's why it happened. Okay, secret is like that, and then afterwards split. Now it's time to split. Okay, now it's time to actually generate the shares. We have converted into numeric format successfully. Now it's time to convert into shares. So split the shares into 5. Into 5. You can do 4 also, you can do how many ever you want. I'm just doing 5 for now, while also requiring 3 shares to reconstruct. At least 3 shares. So even if you convert into 5 shares, even if you have 5 x and y coordinates and stuff like that, only 3 would be required to do the reconstruction. That's how the setup process should be. Only 3 of the parties should be enough for doing the reconstruction. Okay, just for safety purpose. So shares is equal to generate shares. I'm using this function here, what I defined above. So generate shares, n is equal to 5, because I wrote n should be an integer. N is equal to 5, and then comma m is equal to 3, and secret is to what I defined here. Secret is equal to the secret that's here, the secret, right? So I have to take a secret. I've already defined it here. Secret is equal to secret only, I'll write. Okay, m is the minimum number of parties that would be enough for reconstructing. Okay, so let me go further with it. Wait. So what this is saying is that n is equal to 5. As per the generate shares function, n is equal to 5. Okay, I have taken that value. That means I need my n, I need it from 1 to 6. I need my I range, that is x and y values, from 1 to 6. Now we know how Python indexation works. You know that 1, 2, 3, 4, 5. 5 values will be included. The sixth one won't be included. Okay. So I'll explain you the indexation again. Yeah. 1, 2, 3, 4, 5 and 6. I chose 5, right, as n, and my x ranges from 1 to n plus 1, right? My x clearly ranges from 1 to n plus 1. I've written it here, 1 to n plus 1. That means it will start from 1 and end up to n plus 1. My n is 5, end up to 5. That means my range is 1 to 6. My range is 1 to 6 basically. But now how does the indexation work? If this is my range, I need 5 elements. I have written x as 5. That would mean it will be 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, so like this 5 elements will come. That's how the Python indexation works. Okay, what I'm trying to say is that 1 to n plus 1 is my range. If it starts from 1, that means it will end up to 6. But you know how Python indexation works. It starts from 0, 0, 1, 2, 3, 4. I need 5 elements of x, so these are my 5 elements. So it will help me generate 5 distinctive features, 5 distinct elements of x and y. That's what this x is doing. If I'm writing 5 here, that means 5 distinct x and y will be generated using this function 1 to n plus 1. That's all. It's just that I have 5 parties now. I'll get 5 distinct values of shares now: x1, y1, x2, y2, x3, y3, x4, y4, x5, y5. Okay, I need minimum 3 parties only to reconstruct. Why? Because I have defined here t integer, secret integer. T integer means I will just it will basically define how many coefficients I want. So if I have written 3, that would mean that I need only 3 coefficients, including one of them being the secret, to reconstruct. Okay, I would need only 3 coefficients, including the secret, to reconstruct my entire private key that I just converted into numeric format. Okay, so that's all I'm doing here. That's how I'm generating the shares here. Okay, please go through the code, only then you will understand it like properly, and don't get confused, because it's actually quite simple if you look through it through an observant eye. Let's continue. I'll just print f string shares like that. Shares, I want the shares value. I want to see what is generated. Then yeah, if for example, if I want to reconstruct the shares, the secret, from a subset of 3 shares. I just defined 3 shares. I need 3 shares, right? So now if I want to reconstruct the secret, again it's just going to be in a numeric format. I'm not going to do it actual plain text format, because that would mean that the parties have access to the private key, the plain text private key, but they don't. All they have is the numbers of the private key, just different numeric formats, x and y coordinates. They do not have any plain text access to it. This is the plain text of it. Okay, so I would just reconstruct it in the format of a numeric one. Okay, so reconstruct the secret from a subset of 3 shares, right? So pool is equal to, oh god, why is that indentation there? Pool is equal to random dot sample shares comma 3. print f string combining shares pool. Okay. No, I did not close it now. That's why it happened. Yes. Oh, sorry, my bad. Then afterwards, that's all about it. Let's see if it prints properly. Okay. F string shares. Again, I did not close it properly. What the hell? Okay, I missed out one colon. You know, these mistakes are pretty basic, but then serialization dot encoding serialization. Oh yeah, I forgot a comma. Really, here also comma should be there. And this is the last. No attribute load PM. But load underscore PM. Oh, underscore private key. That's why it's just making that mistake. Probably better. Again, spelling mistake and stuff like that. Have the same spelling everywhere because yeah, sample is larger than population or is negative. Okay, wait, what's the problem? Because for and return should come in the same line. I'm just telling for this in this, return this. For this in this, return this. So because of that, if I write it here, then it would create an error, of course. Like it won't raise it here, it will still come green, but actually speaking, that's the error that is raised. Sample is larger than population and all that. So basically it meant that I am choosing 3, I'm trying to reconstruct from a subset of 3 shares, but the shares itself is just one pair. Okay, so it's just one out of one share. I'm trying to create a subset of 3 shares. That's not possible. Out of 5 only we can create a subset of 3, or out of 6, 7, 8, whatever. So that only that error was created, and just corrected it. Now it has come in its correct format. So these are the shares that have been generated. So my numeric key is this basically. These are the different parties that are different parties have got my shares in this numeric format, and then afterwards I will choose different combinations from here. I mean minimum 3 parties from here I'll choose from this list of shares to reconstruct it back to its original numeric format, and then to the private key format when the bank will ask me for it. So that's how this thing works. So hope you guys like the video. I know there are a lot of complexities. It's a new topic. We are still exploring it. But the best part is that we are getting to know about such things. We're getting to know about the existence of such technologies that could, interestingly and creatively ensure that our private key or our sensitive information of the customers, the client, they are, stored in a secure manner. How much we are trying to be creative for them, for protecting and their privacy, their needs and whatever it is. So this is something that as technologists or as programmers or as people involved in this field, this is how we can contribute. This is how we can creatively think about the same, about how to ensure privacy preservance at all times. So hope you guys like it, and for more such videos please subscribe and that's all about it. Thank you guys.